Okay, today we're going to talk about solving quadratic equations by taking square roots. Now, the good news is you've already done this more than likely at some point in math. When you solved for the missing side of a right triangle using the Pythagorean theorem, you used the square root method. Maybe you didn't realize it at the time, but that's what you did. So you know how to do this. When solving quadratics by taking square roots, what we need to do is get the square term isolated on one side of the equation. So, in number one, the first step to do that is to move the negative 121 to the other side. So we would add 121 and add 121, giving us x squared equals 121. Once we have the square term isolated, we can take the square root of both sides. So we take the square root of x squared and the square root of 121. We took the square root of x squared, so we would get x. The square root of 121, we do need to remember, has a positive and a negative answer. We will write that as plus or minus 11. So the main focus needs to be isolating that square term. Once you have that square term isolated, then you can take the square root of both sides and go from there. All right, number two. If we have x squared minus 30 equals 34. So there's something else over on the left side with our square term. We need to get rid of it. So we will add 30 and add 30 to both sides, which gives us now x squared equals 64. Square term is isolated. We are ready to solve. Take the square root of both sides. Square root of x squared is x, and the square root of 64 is plus or minus 8. All right, so just one step, one little extra step there before we can solve. Number three, okay. The square term is already isolated. There is something inside the parentheses there that's also squared, but we're ready to take the square root of both sides when we have this situation. So we'll take the square root and take the square root. Square root undoes the square, so we're left with x plus 5, and on this side we get plus or minus 5. Okay, now we've got to solve for x, so there's an extra step here. And I think it's helpful to split that up into two equations so we can see exactly what it is we're doing. We have x plus 5 being equal to positive 5, or x plus 5 being equal to negative 5. So we need to solve both of those equations each time. So we will subtract 5 and subtract 5. So here we get x equals 0. And on the other one, we'll subtract 5 and subtract 5. And we get x equals negative 10. So two answers. Usually these are different numbers here. Sometimes students will solve one of these and they might get x equals 7 for the first one and they think the other answer is negative 7. That's not going to be the case. So it is a good idea to write out both equations that you're solving so you don't make that mistake. All right, number 4. Looks like we've got some other stuff over here with our square term that we need to undo first. The first thing we're going to do is get rid of that negative 50, so we will add 50 to each side, and that gives us 3 times x minus 4 squared equals 300. All right, now we see we've got this 3 multiplied by our square term out front, so to undo that multiplication, we will divide both sides by 3. Now, if 3's go away, we have x minus 4 squared equals 100. So we have our square term isolated. We are ready to take the square root of both sides. Square root here, square root here. And we have x minus 4 being equal to plus or minus 10. So we need to solve two different equations there. So I would go ahead and write that out. X minus 4 equals positive 10, or x minus 4 could equal negative 10. So we'll solve this by adding 4 to each side, adding 4 to each side. That gives us x equals 14. So here's what I was referring to in the last problem. Some students quickly jump to the answer of x equals negative 14 for the other answer, but that's not the case. You need to solve that one out. Add 4, x equals negative 6. So our two answers are 14 and negative 6. All right, one last problem. So here's one where the square term is isolated right from the beginning, but the number on the other side is not a perfect square. Don't panic. Just go ahead and take the square root of both sides. Square root of both sides. So we get x plus 5 equals root 40. So we need to remember what we learned about simplifying radicals to take that side a little bit further over there. So the square root of 40, some of you may know that right off the top of your head. We could split that into root 4 times root 10, which is 2 root 10. All right, so let's rewrite this. And I should have had a plus or minus there. X plus 5 equals plus or minus 2 root 10. Now we need to solve for x, so we need to subtract 5 from each side. Subtract 5 from each side, and there's a number of ways you can write these answers here. You can write x equals negative 5 plus or minus 2 root 10. You could write x equals plus or minus 2 root 10 minus 5 also. I think I would prefer you write it that way, but either one is correct. So there's a few examples of solving quadratic equations by taking square roots.